Hello students, in this video I will be teaching a new differential equation. This linear differential equation. As you can see, a linear differential equation will be in this form: dy by dx plus py equal to q. Always the first term will be dy upon dx. Remember, how to identify a given differential equation is a linear differential equation. For identifying that, first of all, in this equation, the first term will be always dy by dx. Another thing you keep in mind, that dy by dx term will be alone or should be alone there if any other variable is there with this term, that is, any other variable is multiplied with this term. You have to eliminate that variable and try to get only dy by dx. So keep this in mind, that the first term must always be dy by dx. If any variable is there attached with it, that is multiplied or divided by this one, you have to eliminate that first of all. Before trying to solve the given differential equation, you have to eliminate that. Okay, then the second term is p into y. In the second term, y must be there compulsorily, and with y p is multiplied. The p here and also equal to, in the RHS, q is there, as in here written here. This p and this q, they both can be constants, that is any number, or they can be functions of x only, that is they must be in the terms x terms. Okay, functions of x, they may be either algebraic functions of x, trigonometric functions, exponential functions, any function, but it must be in the form of x terms. Remember, p and q. So let me again explain this differential equation. Linear differential equation will be in this format: first term dy by dx. Here I have written plus, it can be minus also. So plus or minus p into y is equal to q. First term always dy by dx. If any number is multiplied to this one, you have to eliminate that. Second term always p into y. Y must be there compulsorily, and here in the RHS q must be there. And this p and q can either be constants or they can be the function of x only, or both. So whenever this equation is given, first of all you have to check, and after confirming that the given differential equation is a linear differential, it is in this form, or if it is in some other form and you reduce it to this form, first what you have to do, you have to find the integrating factor. Integrating factor, see I have written here, short form is IF. The formula for integrating factor is e raised to integral p dx. What you have to do, the given differential equation, in this equation whatever p value is there, which may be of course in terms of x or a constant, you have to put here, substitute here in this formula, and find the integral of that p, and you will get IF, integrating factor. After finding integrating factor, the solution for finding the solution of this differential equation, linear differential, is this: y into IF is equal to integral q into IF dx plus c. Whatever integrating factor value you are getting here, you have to substitute in this equation. Here y is constant, then IF, whatever you are getting, put that IF value here. In the RHS, from the given differential equation, put the value of q here, whatever is given, into IF value, what you are getting here, dx plus c. And then after substituting integrating factor, IF value and q value, integrate this term, find the integration of this, and you will get the final solution of the given linear differential equation. Okay, now here I have written an example. Let us try to solve this one. what is given here? See, given differential equation is x into dy by dx plus y is equal to x cube. Now, as I explained clearly what is linear differential equation and how to proceed. If you see this differential equation, first term, of course, dy by dx is there, but along with dy by dx, x is multiplied with it. Then the second term is y, which must be there according to the format of this differential equation. And in the right hand side, x cube is there. Again, it is an x function, so that also must be there for linear differential. So everything is fine, but this x which is there with dy by dx, that should not be there. So what you have to do, you have to eliminate that x to reduce this in this form. So for reducing this x, remember what you have to do. The way to eliminate the term which is multiplied with dy by dx, or which is attached with dy by dx, the only way is divide the equation, the whole equation throughout by that term. So here, since x is there multiplied with dy by dx, first step what you have to do, divide throughout by x. Divide all the three terms, this one and this one, by x. So here, if you divide this by x, you will get like this, here like this, and here like this. Dividing all the three terms by x. So x will get cancelled. Here x cancels x cube, x square times. So now after cancelling, what you are getting? Dy by dx plus, you can write this in this form. The denominator you are writing as separately 1 upon x into y is equal to, in the RHS, x square is remaining. Now you can see, first term we got dy by dx, same as the format of the linear differential equation. Second term, p into y is there, and I told earlier that p must be in terms of x or constant, so here it is in terms of x. And in the RHS also x term is there, that is q. So this is reduced, this one, the given differential is reduced to this form, that is linear differential equation. Now after reducing to linear differential, we have to compare this with the format. So comparing with dy by dx plus p into y is equal to q. Comparing this with this. So first term is same. In the second term, with y, 1 upon x is there, with y p is there, so then the value of p will be 1 upon x. And in the RHS, in place of q, x square is there, so q is equal to x square. So on comparing, what is the value of p? We got 1 upon x and q, x square. So we'll write those two values here. Value of p we got, p is equal to 1 upon x and q is equal to x square. So after comparing p and q values, what you have to find? Integrating factor. So integrating factor if is equal to e raised to integral p dx. This is the formula for finding integrating factor. So we'll substitute the value of p here. So if is equal to e raised to integral 1 upon x dx. Integration of 1 upon x is log base e x. The formula for integral of 1 upon x is log base e x. Now in the logarithm, if the base of the log and the base here, if they are same, see here base is 3 and here also log, the base of log is also e. So what you will get? You will get the integrating factor value is equal to x. Whatever term here is there, that will be the value. So if we got x And after finding if, solution. So its solution is y into if is equal to integral q into if dx plus c. Now here in this equation we'll substitute the value of if what we got and q value also, and then we'll integrate this. So I'm doing that here. Because of cost. So y into, what is the value of ix? If x is equal to integral value of q is x squared into again value of if is x dx plus c. So that is xy is equal to integral x square into x is x cube dx plus c. Now integrating this, which formula we have to apply? Integral x raised to n. Integral of x raised to n dx is x raised to n plus 1 upon n plus 1 plus. So here the value of n is 3. So x raised to 3 plus 1 upon 3 plus 1 plus c. That is equal to x raised to 4 upon 4 plus c. And the left side xy. So this is the final solution of the given linear differential equation. I hope you understood.